My name is Justin and I'm a math tutor at Ventura College. Today we're going to go over integration and the substitution rule, mostly known as U-substitution. The first problem, we have the integral of x plus 1 times the square root of 2x plus x squared dx. So when doing these problems, you want to make it easier. That's the idea of the substitution. We want to look for something that we can let u equal, that when we take the derivative of u, we have that whole thing in our problem. So we can either let u equal this quantity or this quantity. And it turns out that if we let u equal this, then taking the derivative would look something similar to this. So let's do that. So let u equal 2x plus x squared. Then we want to take the derivative of u. So du equals 2 plus 2x, and all that multiplied by dx. So we have 2 plus 2x is du. Well, let's factor out a 2. So we have 1 plus x dx, and that's du. So that is almost what we have here. We just have this 2 multiplied out in front. So let's divide by 2 on both sides. So 1/2 du equals x plus 1 dx. So if we look here, we have x plus 1 dx, x plus 1 dx. That's equal to 1/2 du. And then u is this remaining inside part. So now doing the substitution, so x plus 1 dx is 1/2 du. So I'll put that in, 1/2 du. And then u is this part, so we just write the square root of u. And this integral, which is a lot easier than this, is equivalent. So once we integrate this, we need to plug back our x's, and then we'll have our answer. So simplifying this, we have 1/2 times the integral of u to the 1/2 du, which is 1/2 times, we add 1 to the exponent, so u to the 3/2, and then divide by 3/2 or multiply by 2/3. So here we 2's cancel, so we have 1/3. Let's write what u is. U is 2x plus x squared, and all that's to the 3/2 power. And then plus c, plus a constant, because if we take the derivative of this, we should get exactly this. So that's one way to check your answer. And the derivative of a constant is just 0. So for the next example, looks overwhelming, but we can do a substitution and simplify the problem quite a bit. So you're thinking, what can we let u equal? At first, you're always going to fumble around with it, but the more you do it, the easier it gets, and you'll see it right away. It's definitely good to be good at derivatives. In order to understand integration, you have to know differentiation. So what can we let u equal that when we take the derivative, we have that in our answer, or in our problem? So let's try letting u equal the natural log of x. So u equals ln of x, then we'll take the derivative of that. So du equals 1 over x times dx. So we have this 1 over x dx in our problem right here. So it turned out to be the right substitution. So we have the sine of ln of x, so that's the sine of ln of x, which u is ln of x, so sine of u. And then the 1 over x dx is equivalent to du, so what we write is du in here. So what's the integral of sine of u? That's negative cosine of u. And substituting in what u is, we get negative cosine of the natural log of x, and plus a constant, because we have an indefinite integral. Anytime you're integrating indefinitely, you always add that constant at the end. So say you're on a test or you want to check your answer, just take the derivative of this, and it should be what you have in here.